So can you tell me like the operations which we can use on set, and we can see the time complexity for them. Quickly we can experience the preset and then comparable and comparative for them, so that you'll get a better idea like why do we need to go for comparable and comparative. So can someone list me the operations which we do on set?
So like always add. Clear. So is navigable set different?
Sorry, I am not able to get you.
Is navigable set different from set and preset, or
Just
let me compare?
Yeah, you tell me now, Kirpa. Sorry, I was having the fan sound. I couldn't hear you.
So navigable set and preset are all are having common features, right?
Which setup?
Navigable set and tree set are having common methods, right?
Yeah. Basically, all the set will be similar, but few things we will have an additional thing from the navigable and sorted related things. But the basic operations would remain same.
So we have add, remove.
Remove. Okay. Then
Navigable set I see clear function, clear method.
do we have anything else that if you want to set explicitly apart from adding?
We have something to set explicitly based on index of the
Okay. So like, can we all like understand like where this set gets created from? Like whenever you create an object, internally this hash set object is using which map?
map.
So whenever the object is getting created, the internally which data structure is getting called?
Hash map.
Yeah, so hash map is getting called. So what would be the one for tree set and tree map? So you have a tree map getting called. In case of linked hash set, you'll have the linked hash map. So the map is not constant. It's not like a usual interface like map and then like list or set, and the relevant object gets created. So all these maps are again a children. So we use these things and we create an object, and then we represent the set objects in terms of handling all the set operations. So whereas in your array list and the collections like linked list and all, your object is directly created for the relevant child classes only, not from the interface. So in your case, the map interface is just a representative to all your child classes like tree map, hash map, and the linked hash map, and all these child classes are being used in the relevant set classes also. So whenever we use this hash set, preset, and list, or the relevant maps are getting called and not the actual interface map. So we have to ensure that that is clear in this part whenever we create an object. So how is hash map internally working? Which algorithm do we use to provide the index part and then to get the mapping of all the nodes together in the index position? What type of algorithm or data structure?
Hashing.
So what type of thing will be used in tree set then?
reset. So I think it's same.
Yeah, it's same kind of same, but data structure would be kind of different. So we'll see the data structure of tree map and linked hash map once we get into the map part. But the basic structure behind is your hashing algorithm.
Okay.
So with the insertion order, right, which we use whenever we add the data, the insertion order for hash set would remain the same way what we add, or will it get changed in terms of hash set?
So I think it will be changed.
Yeah. So hash set can't maintain the ordering. So there is no maintenance of order here. And here, whatever data you give in the same insertion order will, sorry, not here. In the linked hash set, the same insertion order is being maintained. So whatever you insert, the same data. And in the tree set, it will always be in the sorted format. So whatever data you insert, it will be taken care in the sorted. To do that sorting operation, so sorted data would be there based on the comparator you use for your data set. So now coming to the time complexity of these three things. So what would be the complexity for adding any data into a set?
Order of one.
O of one?
Yeah.
Any explanation on that?
So we are not maintaining any order. We are just putting in one set.
Okay.
It should be order of one.
Okay. And Janaki, what is your observation on that?
Only ash that I remember.
Sorry?
Only ash that I like in previous class.
Yeah, that
I have
is fine.
attended.
You know how to add the data into set, right?
Yeah, with key and value we will add it. Right?
For set, you do use key.
For map only we will use key and
Yeah,
value.
but how do we actually add our data into hash set?
Or similar to list, just the data we will go right.
Yeah,
Like
so the way you create will be similar to your list, but internally that follows your map structure part. Okay, so what type of time complexity would this be taking on addition? It will be O of 1 or O of n or O of log n. So you tell me like about list, like how do you add, like when you add elements into a list object. So what is the time complexity over there?
O of one it is for list.
I think or confirm. We just
O
saw
of one. O of one. Yeah.
O of 1. So in that case for set, what would it be?
It would be same O of one here also. Yeah, because we don't need to maintain that order, right? So it will be O
No,
of
ordering is second thing, but the insertion would again remain with O of 1, right?
one. Yes.
So now removal part. How do we remove it from set?
Here also that restructuring will happen. So if that is the case, it would be O of n. Right?
Are you sure the restructuring would happen as in the list?
No idea.
Okay, like a quick question to both. Like how exactly do we determine our index in hashing algorithm? Which method do we use? Like there's a contract I have explained you earlier between two things. If that contract is not present, you might end up with mismatch of data between two methods from your top class object class. What are those two methods? You remember? Kiruba and Janaki. You both there?
Yeah, yes, Neha.
So we discussed about hashing algorithm. When we are doing the hashing algorithm, when we want to place that data into that relevant index position, if that particular POJO class or your object class is not overriding the hash code method or equals method, you might end up with mismatch of data, right? There's some contract we learned about it. So the 2 points which we learned on object class and the object equals method and the hash code method. What was that contract?
Like if two objects are equal, the hash code should be equal.
If two objects are equal, hash code has to be equal. Okay.
If two has for two elements, if the hash code is equal, it doesn't necessarily mean the objects are equal.
Yeah, that's it. So basically, if your hash codes are equal, it doesn't mean that even your equals method has to return a successful true value. It can end up with false true. So this contact is very much important when you're working on hash set and hash map. So never ever forget, if even if you attend any interviews or even if you're working on a real-time application, if you're not overriding these two and you're trying to use the hash set or a hash map, you might end up with a negative result and not with the what you wanted in the final way. This coding would be remaining same, but this part you might have forgotten, or you have just overridden only one part and not the other one. Then you might have a mismatch and your working logic will not be happening as you expected. So make sure that whenever using hash set and hash map, override both or don't override both. Make sure that this is confirmed in the hash set and hash map. Okay, now coming back to the removal part. So how do we remove the data? So when you remove in your list part, you are having based on the size, you have to switch your data set. So basically in between position, if you're removing some element, we have to recreate the entire array by shifting every data to a previous position and mapping, providing the relevant next address to each location. So there was much more work for removal part in list. Is it same in set also? Because we have a unique kind of mapping happening here for data set to maintain the data and the address location. So the removal part, how does work in the set part, in the set hash set?
So like when two or more objects have same hash code, it creates a linked list, right?
Yeah, it will create linked list, correct. But let's first come up with a positive scenario, like where your hash code is not having, like your hash table is not having the linked list kind of node representation. So right now we'll just consider these three things. So let's have this as 0, 1 index, 2 index, and 3. So now, right now I have only 4 positions and I have all single data. Let's take only this scenario. So if I need to remove anything, do I need to alter that in then 3 position and map back to 2? Or I'm okay to just be like that and remove only the element in that relevant position?
So here we'll just remove the element from the question.
Yeah, so there is no overburden of iterating your entire size of set, right? So it's just O of 1. You're just going to that position and removing it since you have the index. So this will be O of 1. So now coming to your question, what if I have a n number of nodes linked in the position number 3? Right? So in this position, let's say we have 3 nodes, okay, with A, B, and C as the indexes. So in that case, now I'm trying to remove an element from third position itself. So in that case, how would my removal work? It will be O of 1 or it will be more than that?
It will be more than that.
Why?
So it's like the nodes are maintained like a linked list, right? So
Okay.
so I feel it should be over.
Okay. Janaki, your perspective on this?
So
Less than
something
what?
like related to link, like that nodal you said, right? So because of that, it will be off.
Sorry, can you be louder? I missed it.
No, no. Just deleting the data from that queue is will be O of one, but you said we will have nodes in each queue position, right? So in that case, it will be O of n.
No, did you bring Q here, or is it like you just
No,
got it
not
to
the queue,
understand?
not just the set I'm saying, like zeroth position, one position. If you are deleting the record from there, there won't be any readjustments, right? But you said we will have some nodes in each position.
Yeah.
So
So
in
like
that case,
Kirva's perspective is like, since we have the linked nodes here, that might take with a higher performativity because we might need an iteration happening
yeah,
here.
yeah,
But
that's what
I
like
say that
because
it
of
is
that node.
required. I want you to know what is your perspective was.
Yeah, because of that node, it won't be like constant O of one. I'm saying for removal.
So you're saying
Just
it will not be O of one.
yeah, yeah, because of that node thing.
Okay. And now for one more question for everyone. Like in this node, I have say index A, index B, and index C. And index A is having some value and pointing to the next element. If the next element is not present, that would be null. Okay. Now, for each node, do I need to generate hash code or not? Before inserting some element as a node, will I be generating the hash code here?
So before inserting, we'll be generating the hash code.
Mm-hmm.
So in the event if we are getting the same hash code, then it will be stored in the same bucket, right?
Yeah. So only if the hash code is like same, we'll be moving it to the relevant index position and connecting those nodes. That is what we do.
Yeah.
But now anyway, we have validated the hash code, right?
Okay.
And for every hash code, you have the relevant value too. Equals method will be taken care every time. See, whenever I'm giving the method hash set dot remove, the relevant object dot remove, so I'm actually comparing it from my map. So right now in my map, I have the index position 3 with some value, okay, some data, which is having a linked value. So whenever I call this remove method, will I be directly removing it or I look into the nodes? So if suppose we have linked nodes, like in our scenario, if we have 3 nodes in the position 3, so I will be checking the hash code for every element. So whenever we compare hash code, we internally check the value as well. So in that case, we are not dependent on iterating. We are just dependent on the hash code and key. So which is again like O of n and not O of n. We are not moving its position, right? We're just making it null if we don't have next address. Otherwise, we just connect them.
I don't get it. So
So let's say for our scenario, I'm coming for this position. So I'm trying to delete this one. Okay. So if I'm in this position, I have a relevant hash value for this particular node and value, and then the next address. If I need to connecting to the next position, I'll have the next address. So when it comes to the implementation, it first compares the hash part and then it compares the key. The key is nothing but your value. And since the index is 3, but still you are figuring out the value from your key node. The equals method will compare the value and then the hash code. So it is comparing the hash part as well as the key part. Only if they are true, we are going into that node and we are removing it. That is what on the removal part we do. So if I'm going it, let's say this value is A, this is B, and this is C. Okay. So now I'm trying to remove B. So when I'm trying to remove B, since this is not array index position, I have key position here. So based on that key, I can quickly check and see whether this holds a value or not. And only if that satisfies, I need to go here. Otherwise, I quickly go here and check the next relevant node. So that is what the implementation looks like. Maybe you can check here. So I will compare the hash key, and if your key is matching and if your key is not equal null, it is equal to key, you are assigning it to node. Okay. And the next element, we again check. So right now in our first node, we have the next element connected to B. So we again check it is not equal to null. We again do an iteration on top of it, and we come back and we assign the node. But the deletion part is only thing which we do in this deletion part is the B gets removed and that key value will again be removed. Only the A position address has to be replaced to the C position address if we are linking it in the index 3. So the time duration which we take in the usual array list and the set would remain same or it will be different. If I'm doing the same thing in an array list, sorry for bad representation. So if I need to remove this position of 2, then what would happen in case of array list? You have to migrate, like you have to exactly take everything after 2 and prepone it to the previous index along with the data as well as to your addresses. Right? Because your data will change from 3 position to 2 position, and then your address gets changed in all the positions of your next places. So there is a two-way of upgrading it. One is data, another one is address. But when you come to a set, like are we actually dependent on the data or only on the address?
Only on the hash code, right?
Only on the data.
Sorry.
They depend only on the data.
So now let's say I have this B node. Okay. Let's take 3 things. This is data is A and the address is A address. Okay. And this is B and B address. C. Sorry, I totally messed it up. This is C address. So A and it has B address. It has B and it has C address. And it has value C and this is nothing, so it is null. Okay. Now, when I give A to B address and B to this address, right now I'm trying to delete this part. So what happens now? So wherever I'm referring this one, the C location alone, this particular C address alone has to be updated in my A address. So instead of BDDR, it will be updated with CDDR and there's no change on data. This data is completely removed now. So only is my address getting changed. And when I come back here, this would be the last node. So I'm not responsible to change the data here, but I'm responsible to update the next address to the previous nodes. Is that what we do in the set, or are we dependent on changing the data as well?
Okay, we are checking address only.
Yeah. So then compared to your array list, the where we do the data check also different. And then we come because this is all happening in the same index position. So there is no change for your index part. There is no iteration on NM elements. The elements of iteration happen only with the linking node, which is like more easy because it is only key value pair. Only the address part has to be changed, taken care of. So compared to your array list iteration, the set iteration is very minimal. So which is again like less than n. Not even n, it is less than n. So even in the worst case scenarios, we again come for the removal part with only O of n and not greater than n. Because the number of iterations which we do in the list is completely different compared to your set. Are you clear or any questions?
Yeah, okay, sir.
Janaki?
Sneha, can you repeat that last point? The number of iterations we are doing, something is that right? Can you repeat that point?
No. In your list, whenever you delete something in between, right? You have to replace your entire data to the previous index positions, right? Suppose if I'm deleting 2, my position for the third will become 2, for 3 will have the 4 value. And then for 2 should have the 3 address and 3 should have the 4 address. So where I'm responsible to update the addresses from the
as well as
data
data.
getting deleted as well as the data, like because the entire position itself is getting changed, right? For 3, right now whatever you have in 3 is getting moved to 2.
Yeah. Data
So
and
there is a
address
change
both
for
will be.
data and address. Whereas in your set, you are not responsible to delete from this part, right? Now when we do only deletion on this part, we obviously know the key and we go and delete from there because it's unique key and unique value. You don't have duplications. So it is very direct. So it's O of 1. But when you have kind of linked connections, in this case also, we are not dependent on data. We are dependent only on address.
Yeah, got it.
Right? If any part is getting removed, only the previous node has to be updated with the relevant address. Instead of B address, I'm going to update it C address. That's it. Apart from that, I'm not updating data. So the number of iterations again not very high because internally you're using hash code method, which compares your data, compares your equals method and hash code method comparison. So where your removal part or identifying the value from your entire node is more better than your array list.
Okay. Yeah.
So the iteration would not be O of n.
Okay.
Because internally the hashing algorithm is playing a major role. That is why we have a less complexity in case of set. So that is the reason whenever you wanted to improve your performance, even if you have duplications, what they do is usually they create everything in list and finally they convert it to set if they are not dependent on duplications. So for example, if you have a login, you're going to trying to log into an application like Facebook or any unique confidential application, you can't have a more than one Gmail getting connected with that. You always have only one Gmail getting created because you should not have more than one. That is what the duplication is not allowed here. So in such scenarios, you go with set. So the handling part would be more easy. But there might be few applications. How many times you give multiple email IDs with the same name, it will still accept. So multiple names, same email ID, it will accept. But few applications will not accept, though you give multiple names and the email ID will be like a unique thing. So those times you have to ensure like which comes in front, like either list or set, and what is your use case and whether you're dependent on performance or not. So if you're more performance oriented and you don't want duplications, you go for set. I'm okay to take the burden of the performance, but still I want duplications, then you can go with list. Okay, so next coming to contains. What would be the time complexity for contains?
So time complexity for contains will be, so if you pass something, we are going to calculate the hash code. See if it is there.
So the contains is again basically going to check the entire key set. So now this is right now key set part only. You don't have the value set part only. You don't have the key set as you have it in your map. So whenever you give contains, this accepts only values. It not accepts keys, right? So let me go quickly to the code. So what is happening here? Let me open the array list also. So here we contains check is happening based on the index. So wherever you have your positions, you go and check the value is present or not, and then you come back. Now, in case of your hash set, this is again basically key. So you already have a unique hash code getting generated every time. So when what happens when you create your contains key is getting triggered, it will obviously go and check the relevant hash code value, and if that matches, it will go and retrieve your data set. So there is no much complexity as you have in your array list. So in that case, the execution would be more faster than your list, or it will be still same.
Faster than list.
Yeah. So in that case, what would be the complexity for this? It's again O of 1. So since you have the hashing algorithm implemented, the complexity for all your operations would be in a constant frame. It will not be in N. It is always with the best with constant frame. Because everything is again dependent only on your key and value. So hash code is playing a major role on your retrieval as well as to update or remove or to identify anything. So the hash set is kind of like the best if you don't want to maintain any kind of dictionary things, then it's always better to go with the hash set. This is the one which we use. So like, are you clear till this one? So anyway, the set is again same thing. You don't have an additional set part, like additional burden like you have in your list. It is again similar set one. So you can also tell me the set part, how actually it works. Because getting the bucket location in all these cases is very easy because you have your hash code internally maintained. So that is the reason we don't have a difficulty. So what happens for set? Janaki, your perspective on this?
Then in that case also it would be like O of 1 because we are anyway dependent on hash code only, and it will not be like complex. So it would be O of 1 for set also.
Okay. So now you got an idea on the complexity of
Yes, Neha.
okay. So now coming back to linked hash set. Okay. So you know what is linked map or linked list, right? So what is the difference between array list and linked list?
So we maintain previous node address.
Yeah, we maintain the next and the previous addresses. So will the same happen in case of map, linked hash map?
Can you repeat the question?
Will the same happen in case of linked hash map?
Going by the name progression, yeah, we expect it to happen.
Okay. Like can someone say like me like this is the hashing algorithm which we thought, right? So in linked hash map, what would be the structure for ABC? Like right now I have only A and next address, right? So what would be in case of linked hash map?
It will have the previous address.
Okay, you have the previous values. Okay. So what other things can be a problem here compared to hash map or hash set?
So when we remove, we just need to update address into nodes.
Okay. Okay. So is my linked hash map a child to hash map or is a separate child to map?
So child to both.
Child to both of no. Like I'm asking it, the hash map and linked hash map has a relation because whatever we see in the array list and linked list, list was our parent interface, right? We were just having our own child classes which implements the interface structure. So we were having the array list implementing the list interface or the collection interface, right? So which implements this part. So this extends only abstract list. So similarly, when you see the hash set, that extends only abstract set, okay? But if you see map, okay, map is an interface, right? So in that case, the hash map should also extend the abstract map, right? But in this case, this hash map is extending abstract map. But in case of linked hash map, that is not happening. It is just extending hash map and implements map interface. So here I'm not getting abstract hash map. Instead, I'm getting the other parent, which is hash map, which is directly extending my abstract map. So the hierarchy is kind of abstract map, and then you have your hash map, and the hash map is implementing the linked hash map. So this is the hierarchy. So when you are implementing this this particular parent hash map, you don't need to explicitly implement the actual abstract map. So what kind of hierarchy this falls into?
Multi-level.
Yeah, multi-level. So when you have multi-level, you don't need to tell the actual parent class. You can just mention your immediate parent class. So coming back to this thing. Yeah. So the linked hash map actually extends your hash map. So now what all other things we might have as an add-on when you come as the linked keyword, like similar to linked list, what are the things we might need to consider when we are trying to generate hash code and equals method contract? Because now your node structure gets changed. Earlier you had only key and the relevant address. So it is more of this. So now going forward, your linked hash map, I'll represent both so you get an idea. So earlier you had only the key, value, and the next address. This is what the usual representation we have here. Now, in case of linked hash map, what would be the notation representation?
Previous address, key value, previous address, value.
Address, key, and value,
and
the next address. Okay.